that you know SQL, then what's the objective of doing the or reproducing the DPCDS benchmark on your own PC? Anyone has any idea? Yes?
Well, I imagine it would be to know like how to run a benchmark and how the other enterprises would present it, and also know like when you have a data warehouse, what kind of operations should you be looking into for executing them. That was what I thought.
I didn't get the second part.
What would be the queries and the actual functions that you would typically use in a data warehouse?
So maybe I will go for the first part of your answer, Nicole. Why is it important for you? According to my understanding, why it's important for you to understand how to do a benchmark? Are you any time in your life, what are the probability that you work in a benchmarking company in your future career? Almost zero. So why you are telling us that this is important how to do a benchmark? Yes?
Because we may face a situation in which we are, for example, hired by a company to decide which DBMS to use for a specific application, and a benchmark will be the way to go for us to decide for one of them.
The other thing is that problems are very different. So if you're in a company and you have a specific problem, one DBMS might be better than other. So a good way to check if it's gonna be a good fit, because from what we heard from the spec, DPCDS is designed somehow similar to a sales scenario. So if you have a problem like that, it could be a good benchmark to see if the database you're planning to use for that is good.
So this is the first idea. I don't know, my example when we were discussing with some of you after the lecture was, suppose that I need to buy a new car or a new bike, whatever you prefer. I don't know, you have in front of you so many options, and suppose that, for example, you are using a traditional car, engine, either diesel or more traditional ones, and then suddenly you are in front of you the possibility to buy a hybrid car or even a Tesla. How do you do? Suppose that you can afford. I don't. But suppose that you are in this choice. How do you orient your choice? On which factors you will base your decision? One at a time, maybe, or yes, Blanda, you were asking.
Compared to cars and compared to price to the speed, how many hours we need for per 100 kilometers. Also factor, because maybe we have a big family, maybe we have only two person need, and also some factors.
But you understand the problem. You have so many choices. You need to prioritize your criteria. Are you prioritizing family, comfort, ecology, cost? For example, people in the car industry are saying that yes, it is nice to have an electric car, but how much it will cost after 5 years of maintenance? How much it will cost having a normal car? How much it will cost a hybrid car? So this long-term maintenance is also an important factor. So the same, going back to our problem, you need to identify what are your main criteria in order to build your application. Some of you already stated one data warehouse is not necessarily the same, one application is not necessarily the other, and you need to identify how this database tool and this will make your application, which has very precise requirements, are performing, and how. So this is why somehow many of you have asked the question: how much can we or must we respect the requirement? We are not a TPC company, or we are not working on Microsoft or Oracle trying to prove that our database is better than the other. For you, it's very pragmatic. We have a typical scenario application. I mean, you have all the scenario, the different applications in real life. But suppose that we have an application that has many similarities with the one that is proposed there. How much will your software and hardware be able to provide you answers in reasonable time? This is what I meant. This is why I didn't mention that you need to go to the scale factor 1. This is not important for me. What I mentioned is that estimate how much data you can put on your PC. This is your 1.0 factor. Then try to measure the same queries with .1, .2, and .5 and 1.0. And then you can have four points to make graph to see how much your queries are linear or quadratic or exponential. So this is the idea. To understand whether your boss is saying, okay, I need this answer in 5 minutes, you say, no, come on, it will take 2 hours in the minute, because then you are able to manage and discuss with technical terms why this query cannot take 5 minutes and he needs to go take a coffee and then come 1 hour later. So this is the very pragmatic way to for me to understand why is it important to have understand how to do benchmarking. Second aspect of Nicole's answer: typical queries. So basically, these are typical queries in which you will find while building database data warehouse application. Is by chance anyone, and then that will come with some the tools, different tools that you are working on. It's important. Anyone by chance working on, what was the tool I received a message this weekend? Let me see. Sami Abdul Satter is not here. No, he's not here. Someone told me that this weekend that they have in their database, they don't have group by rollup and group by cube. And then the group was panicked and saying, I already solved my database. Do not provide me the possibility to do standard deviations. I programmed myself this, but we are blocked because for 11 of those queries I don't have the possibility to do group by rollup and group by cube. Is it dangerous? I mean, is it how would you respond to that? Suppose that you are using a database that does not provide this functionality. And suppose, I don't care about the project, but suppose that you are in a concrete environment, working environment, and then you have this problem. The tool you have does not provide these two operators. Is it problematic, very problematic, mildly problematic? How would you react to that?
I think I'd look to understand the business and what's the problem I'm looking to solve. Do I need that particular function, or does that function exist in a different way that can still be applied? And then I would just apply it that way, or choose to not use it. And I don't need to evaluate it because maybe our business doesn't need it.
Good point, but suppose that indeed you need it, and don't remember, you remember what does these two operators do, group by rollup and group by cube, yes?
Were we talking about the standard deviation thing, or we're talking about?
But the same thing, standard deviation. Let's start with this.
I in my case, if it's for the benchmark and I can find another way to do it in the DBMS, I would see two options. Either find code that's already done, just to not reinvent the wheel because it's a function that probably somebody programmed better than me. And if I can find it, I'll just do it myself.
So typically this group, I don't know, found a way, I don't know whether it invented themselves or find a solution how to program standard deviation by intuition. Is it so complex to provide to extend your DBMS with a standard deviation function? Is it very, very complex? No. So this is not major problem. Let's go to the second problem. Do not have a group by rollup and group by cube. What does these two functions do?
You can use union all.
Sorry?
Union all that is the alternative group by.
You step you give one step ahead for what I wanted. Yes, it did. We can program it, not very complex by union. But if we think what does these two functions are, what is the objectives of these two functions with respect to traditional group by?
They're providing some aggregate values.
Some aggregate subtotals. Let's put it in subtotal. You have your individual total with all the combinations of, I don't know, city of the customer and city of the supplier, for example. And then a simple group by does all these, and group by cube and group by rollup just add some additional subtotals. Is it a severe problem to not have these subtotals? Not very severe, because why? I don't know, you put that into a table and then you do a simple loop in whatever PLP, GSQL or PLSQL or T-SQL, whatever programming languages you have in your programming, in your SQL database, do a simple loop and you keep, as soon as you change for the next value, you print the subtotal, okay, for that. So you have an ordered list, or you order your database, your result table by the first argument, second argument, third argument. And then you have three counters in your programming language. You know, it's a simple algorithm to do that. Union is possible, but union is not very efficient because you need to do an exponential number of combinations. So suppose that you have by customer city, by date, and by supplier city. Suppose that you order your output table from a group by in these three first this, second this, and third this dimension. So you have in memory three simple values, variables, and you get you read the first three values, and then you look. As soon as you have one new value here for the one that you just read, then you print the subtotal that you have already been computing, and then to the second, and then to the third. So basically, it's not rocket science to, if you don't have this into your database, producing the complex part, of course, the group by. Once you have the group by, you can simulate very easily with 10 lines of code how you can do that. Okay, for that. Now, an important factor. So basically, again, it is not very important. The complexity you are measuring is the complexity of the group by. Then the group by rollup and group by cube just is a linear scan of the result. A linear scan is not very expensive. Okay, for that. Now let's talk about why it's important that I force you, and then every year I have to really force you to do different tools. Why, for example, some of you are using, I don't know, SQL Server, if I remember it was you. Some of you are using other tools. What are your experience? For example, if I ask you, what are your experience? What did you learn trying to implement in SQL Server?
guess in our case we were lucky in a way because SQL Server, like for example, the standard deviation thing that you mentioned, when we generated the code, it didn't work because we couldn't translate it directly. So we had to do it ourselves, but in our case, SQL Server is so widespread that it already has a function for that, so it was easy to solve in our case. So, I mean, I would see how it's more challenging if you are using like a different database completely. But in our case, the process has been more of trying to adapt what the TPCDS spec has in order for it to work correctly in SQL Server. So, in a way, it's that like, I mean, in our case, we've discovered some things that we didn't know that we could do. Like, for example, when we were doing the division process for the minimum test, that you can do like deletes and joins at the same time. I didn't know we could do that, so that's something. But in our case, I believe the DBMS was a little bit more easy to handle.
And someone else with a different experience with problems in their own tool? Yes?
So we were working with MariaDB.
MariaDB, yes?
Yeah, and we could see that with the standard DBMS, we could do the grouping function. With MariaDB, we were not able to do that. So we were need to, work around to make the query, to execute the query.
Someone else? So the idea is that also you are confronted with the issue that the tools are not equivalent, if only for the syntax, because here we are talking about the syntax, but then of course it's already enough work for doing a single tool. This is why somehow in the other advanced database course, each time you have a single subject and two different tools, I try to merge the two groups into a single one, just to understand that we have two options or more options to choose a tool. It's important that you at least you are able to assess in your particular context which tool will be better than other. So this is also an important thing. And understand, for example, that in some cases the traditional databases like SQL Server or other relational databases would be, you land in a company using that, so there is no problem. But you would also have the possibility to land in a company in which they do not want to use traditional, they use, advanced. They use non-traditional, key value stores or something like this, and then you need to adapt be able to take code, SQL code that works for SQL Server that everybody knows, and try to translate it according to the possibilities that the new database that you are working on offers. And so you will have blockage for that, of course. So this is again a learning experience. And my last point in this discussion was how much, what are the minimal requirements? I sent you a graph from a previous year report. The figures are not important, but that was a nice way to visualize how the different performance of the different queries in various scale factors can be with visual. In 2 seconds you can immediately identify the problematic queries, okay? So if you see the graphs that I sent you, you will see that there are, I don't remember, 5 or 7 queries that take too much time with respect to the other queries. Then what the minimal requirements, as I mentioned, would be that you are able to execute these 99 queries, or a variation in the case that people that are not able to do the group by Q, for example, but some variation about these 99 queries. Then what remains out of after that, it is your choice. So this is an open, again, a pedagogical objective. The minimal thing that you need to learn is to run these queries. After that, you can learn many different things. One particular case that we discussed already with some of you, how to improve the queries, those 5 to 10 queries, of course you can optimize the 99 queries, but this is not, you don't have time normally in life for doing all the things that you could do. So you need to choose on what work you will get the best return of investment. I'm sure that from the 99 queries, you suppose that you are working on a real environment with a real manager. From the 99 queries, you optimize 5 out of them. The most problematic one, your manager will be happy because he will not wait for 1 hour, but he will have the answer in 5 minutes. Then a bonus point or a bonus work or I don't even want to discuss about grades, because grades for me are not important. What are important for me, you learn something, I myself also. So in this context, you could learn how to work through the code and then try to rewrite or make things happening faster for these 5 queries. In the other courses that you are following, the one, for example, in database system architecture, you are more or less learning a little bit learning the essential ideas, how to optimize a query, how to read the plans, how to rewrite your query so the plans are faster. So again, this is a nice experience that you can do if you have time for doing that. Other suggestion that additional work that you can explore, you mentioned what other
So there's comparing query runtimes, optimizing slow query, running additional benchmarks. So like, because you just said, if we can run the 99 queries, TPCDS goes through and says, well, there's still the data maintenance, there's the throughput test. So
let's talk about these two. What is throughput test according to your understanding? Did your manager read something? He doesn't understand a thing. And how is your throughput, Adam?
So the way that I would, sorry, you're the manager, but you don't understand the word throughput?
I heard that this is important.
Okay. So throughput, the way that I understand it, is the ability of multiple users to access the database at the same time. So how well does the database perform when there's multiple users using it?
And so after this, the definition, why is it important to do this benchmark? To measure the throughput of your application.
Because the database will be used by multiple users. So if 100 users, if my database is like that, only 100 users can be accessed constantly. So in that case, if 1,000 users want to access that, then the database will be like in local space.
So the idea is, suppose that you are creating a new application. You are creating a new application. Of course, you are betting that your application will be successful. The first time you launch your application, it will have hundreds of users. But then you became so successful that immediately you get thousands of users. So you have one order of magnitude bigger. You need to understand what will happen if you are successful. If you build from the beginning and without this parametering in your design, and suddenly when you are successful, you are not able, you need to rewrite, change the database and rewrite completely your code, it is too late. You should have done this analysis before. Of course, I'm not telling that you need to do that because the project is open-ended. But if you want, you at least have some reflection on how would you do a throughput test. That's already you show me that you learn from this experience that yes, that could be important. I foresee, I didn't have time to go to the end, but I foresee that I will do this in this way because this is an important factor. You mentioned a second one. Throughput was one and the other.
Data maintenance or data refresh?
The data refresh, why is this important? Yes?
Because you most likely won't be dealing with static data. Data will change across time and computing changes in the database, especially if we're talking about a data warehouse, it's expensive so you need to take into account that time because that's what's gonna tell you like how long you will have to wait for reports or analytics and that kind of stuff.
So this aspect in particular is studied in the next project in TPCDI. In TPC, if you had already problems or the stress with this TPCDS project, then you will have to be prepared to have much bigger problems in TPCDI. What is TPCDI? TPCDI, you have CSV files, you have input files in many XML formats, and then you need to put all these to arrive to the database that you are starting from TPCDS. So in TPCDS you have one database, and basically you are asking to be able to put this data in your DBMS tool and write the 99 queries. Now the other part is you have, I don't know, CSV files, etc. Then you need to manage all the problems that you will have with consistency, with evolution, etc. in order to arrive to the starting point of the first project. So you need to tackle how all this data will be able to enter into the database with, this is a complex problem because this is not as well standardized as the SQL. You know, you have problems already with SQL, but here you will have additional problems because nothing is standardized in that. Even the TPCDI standard is not very well used, simply because the tools that you are using for doing ETL are not necessarily good all. And then of course it works for smaller data sets, but for bigger data sets, even the most expensive ones, they are very bad at that. And finally, you will have the real problems are coming after the 1st of November. Okay, for that. So the idea here again is, at this moment, sooner or later, all this process that can take arbitrarily long time, can be take 1 day, 1 week, before preparing all this data to enter into your data warehouse. When this data enter, you need to somehow stop the data warehouse during how much time, and then add new data with the sale for the last week. And then you need to assess how much time you will need to do that, and then what you will do with your user during this time period. So again, it's a completely different problem from the original simple problem of running the 99 queries. So in essence, you get the idea. I don't really care about grades. What I'm really cared is how much do you learn from a new domain, and how well you are prepared to launch your data warehouse application when you finish your studies. So you get the idea. The minimal requirement is to have these 99 queries running in somehow, compare the different scale factors, and after that, it's up to you. How much time do you have? I know that you have other projects in other courses. This is why whatever you do in addition, this is bonus point. Okay for that?
So sorry, just to be explicit, running 99 queries or their variation plus running at multiple scale factors is a minimum requirement.
Yeah.
Thank you.
And then after that, you show me things that you have learned in your experience. For example, one question that for me it's interesting, I don't have the answer, is for example, as you will see, SQL Server, they have, for example, a relational database. We will see the topic today, relational data warehouse, or you can have a cube on top of that. And then, of course, you have different languages for the SQL relational database and for the data cube. It will be SQL versus FDX or DAX. One question that I never had time to do this benchmarking is how much penalty. how much penalty I have when I use the DAX or the FDX or the cube with respect to how much I gain with respect to SQL. In a relational database, should I delegate the cube manipulation to Microsoft, or do it myself because I know my application, I know my data? I maybe have faster ways to do that Microsoft cannot suspect, because they are doing a general tool, but not something which is customized for my application. So if I know very well my applications, of course I can program better SQL queries than whatever SQL query Microsoft SQL Server could generate. So again, this is for me it's an interesting question that I never had the time to explore. So think of an interesting question that you would like to explore. At least I don't know, if you don't have to do it, discuss in your conclusions things that you learned, things that you would like to explore in the future in order to be sure that your application can be deployed and will run at scale. So for me, that's the pedagogical objective of this exercise, and out of that you do whatever you want. Okay?
Thank you.
So now let's start with the relational databases or relational view of the data warehouses. So now we are going into logical database design. You remember I showed two different languages, conceptual languages for describing the data warehouse, the DD model, the DFM model. So at some abstraction level, wherever you are using SQL Server or Oracle or other database, the conceptual model will be the same. Now you have this conceptual model, and then you can have a very different logical model for the technologies, for relational, for columnar stores, for key value stores. So the same conceptual model, you need to implement it in your particular technology. I'm not talking tool, I'm talking about technology. This is why in the other course I insist very much, differentiate technology versus tool. Technology will be key value store. Tool will be MongoDB or whatever. So when you have this conceptual model, you need to choose your technology. In this case, we will be using relational technology. What will be the way to transform a relational, generate a relational schema for the multidimensional schema? So this is why it is called roll-up. Roll-up meaning relational roll-up. It's an OLAP layer built on top of relational database. Why is it the case? Because relational database have been there for 50 years. So yes, 50 years in the 1970s. So this is a technology that is very mature for storing. We can say at some level of abstraction, infinite tables. You can have as much large tables as you want. So, and out of that, then you delegate the management of these huge amounts of data to relational database. On top of that, you can use OLAP philosophy to build cubes on top of this relational store. But you have also, for example, even in SQL Server, you somewhere in some menu in the physical implementation of the database, you need to choose whether you use roll-up or mol-up. If you are using, for example, DAX, DAX has been designed for in-memory databases. Why in-memory columnar databases? Now that you are a little bit understanding this domain, what would be in-memory columnar database? So the same database, TPCDS, you can implement it in Rollup or MOLAP. And the MOLAP version in SQL Server is accessed through DAX, and DAX has another database inside, or a SQL Server has another database inside, which is not relational, which is columnar in memory. Can someone explain what does this mean? Yes, Nicole?
I could try to, what I think it's like, it's storing the data in the memory instead of the disk, and instead of being the whole row, like each row, it will be each column. So I could imagine that if you're aggregating like sums of columns, it could be faster to do it that way than like going to check for each column, which would be in a different space in the memory if it was row-wise instead of column-wise.
Yes?
I have a question. Is it true saying that rollup is a technology to implement a conceptual model?
Yes, definitely. It's one among many. But another alternative very one is the one we are discussing, MOLAP, which is multidimensional lab with a completely different technology which is not relational. And then, does this answer your question?
Yes, so MOLAP is the equivalent of rollup, but for doing different things.
For storing data differently.
Okay.
But the DAX language provides the same, should provide the same expressive power as equivalent as SQL, even if it is not exactly the case, but you can think DAX as the same as SQL, but for another storage. So, can we continue 2 minutes with this idea in memory database and columnar store? Why Nicole did what they say, Nicole said is exactly correct, but why is it important to understand yes?
Well, if I would store a column, most probably because I would do some aggregation function on that column. And the reason could be that you're gonna perform some aggregational functions over a couple of columns at the same time.
The idea is indeed that we have mentioned before that our house has 50 dimensions in average, and in a minimal is 50 dimensions. Are you wanting to display in your dashboard 50 aggregations in front of for your manager? No. He asked, give me the product by the sales, by customer, client, by date. Here are three. You can also guess how much dimensions you have in the 99 queries. Now you are knowing better than me. What is the average number of dimensions you are asking in the 99 queries? Is it 2? Is it 3? Is it 5? Is it 10? More or less. How much dimension you aggregate in your SQL queries? It's around 5? It's around 10? It's around 20? How much? 10, 20 or 50?
I would believe it's around 10, but don't quote me on that. I would believe because if it's a data warehouse, there should be just some central facts, I believe, and most of them. And I've seen like a lot of joins in the query, so my uneducated guess is 10.
Yeah, so it's about that. And then what happened with the 40 other queries, 40 other dimensions? We don't need it. And in addition, when you have, I don't know, all the values, typically how this columnar store work. You have a column for customer client. You have, of course, a pointer to the row to link the different columns for the same fact. You have another column for the date, another column for that. All these values here could be repeated. You have 1 million rows, but all these values could be repeated, I don't know, many times. Then you can compress a single column by in the same way that zip files or the zip algorithm does. They just count how many occurrences of a single value, and according to that, determines whether 1, 2, or 5 bits are necessary to represent this particular value. And of course, the more frequent values have less bits, and the less frequent values have bigger bits. So there is compression algorithm that you can apply inside a single column, and that you cannot do when you have all the possible combinations about the 50 possible values. You get the idea? Therefore, this is why SQL Server does this, because the memory, of course, is very expensive. You cannot have terabytes of memory. But by compressing individual columns, you reduce the size of the data warehouse considerably, and therefore your data warehouse will most probably fit in memory. But Microsoft tells you very precisely, if it does not fit in memory, they say for very large data warehouse, of course, this is a marketing comment. Sooner or later you will have reached this limit. Then what happens? Then you are not able to use this columnar database, and then you need to switch your storage to a more traditional relational database technology. And therefore, but the idea is that the same queries, whether in DAX or in SQL, you can execute it either on the columnar storing memory or in the relational database. And internally, when you switch to using DAX on relational OLAP, your DAX query will be translated automatically by Microsoft into SQL queries. And then by logging into the database, you can even see the translation of your DAX query, how it is translated in SQL, and then you can optimize your SQL query. You get the idea? So, again, you have the same PCDS queries already in relational databases, as simple as SQL Server. You have the possibility to choose the logical model in which you would like to implement your data warehouse. Of course, some of you are doing cloud data in the tool for TPCDS. You have I don't know, ClickHouse or some other cloud data warehouses. These people are using, of course, typically columnar database in the cloud. This is the traditional. This is where huge companies have made the difference, because they use on the cloud columnar databases, whether in memory or not. But this is the way how Microsoft entered into this domain very late in memory columnar database, because all the other companies were having already billions of dollars, and all these companies were stealing the clients from Microsoft. And immediately Microsoft needs to do needed to implement something similar to keep his customer base. Okay. So this is the multidimensional OLAP, and then there is a third implementation, which is hybrid OLAP, and that exists in the beginning. For example, in the case of SQL Server, you can have, for example, relational OLAP for the base data, and then for the views, materialized views, they use MOLAP, but not for the full database. Only for the materialized cube, for the cube part. So again, you need to, at this level, you know, at the level you are doing, it's impossible to assess which of the three implementation is the one to choose. It is on when you run a real data warehouse with real user and a real throughput. that then you need to benchmark the three possibilities and see, and then say, today I have that number of clients, in 1 year you add one order of magnitude, and then they say how, given this order of magnitude, this additional, instead of 1,000 clients, you have 10,000 clients, how much of this relational MOLAP or MOLAP will be the best solution in 10 years from now, okay? So this is, we don't have been, that depends really on the application required. But at least you need to understand that these three implementation exist. Traditional table structure for data warehouse is the star schema. I suppose that you already know the star schema, in which the fact table is in the middle, and you put the keys of all the dimensions that are related to your fact. And then you have a single table for each of the dimensions. These tables are, of course, denormalized. I mean, that the same product, you have 1,000 products for a particular category beverage, but you have not only this, putting the information about the category, all the 1,000 products having the same category will have these attributes repeated. So we have a lot of redundancy. Is it dangerous to have so much redundancy in a star schema? Yes?
I would say it depends, but if you are doing reporting, it is usually not that bad, because that means you avoid doing joins in real time, especially if you have like a direct connection to the data source, so your dashboard will be fine. So sometimes it's by design that you want it to be different.
Nicolo, you were saying that it is dangerous.
He is Nicolo.
Sorry, you are? Pietro, sorry. Pietro, you were saying that it was dangerous. Can you express yourself?
I'm not sure, but I think that if you have, it's like redundancy, so you have to take care of changing it.
So indeed, the problem of redundancy is not the redundancy per se, because the cost of additional terabytes of today is almost nothing. But the problem is indeed you need to manage your redundancy. Suppose that the category description and the category name change, or then you need to be sure that your update for your new category information should be consistent across all the products of this category. And that means a SQL query. And you be sure that your SQL query is well written and you consider all corner cases. Okay? So this is the problem. But also somehow, so you are right and you are right. In the sense that the redundancy here is not very, provided that you manage properly the evolution of the data here. Here we have millions of rows. Here we have 10,000 products. If you have a normal company. So avoiding to have for each of the 1 million facts there, you need to do a single join for a product, and then you don't have to do another join for a category. If you want to do a normalized data schema without any redundancy. So the idea is that this table is orders of magnitude bigger than all the others. And what is important is the join. The join is an expensive operator, especially if you have millions of rows in the middle. So this is why it's a compromise. How often do I need to do an update of a category name or something in the city, or even the city of the customer? Of course, the customer changed. how often it will be? Once a week? Once a month? But here we have to run thousands of queries for reports continuously, every second. So it's important to optimize the joints in this perspective, but again, I still insist that Pietro is totally right. Managing quality information in a data warehouses passes through managing redundancy, and this is a complex problem to do very well to be sure that the information you show to your manager is always correct. Okay? So maybe we can have a quick break and we continue immediately after.